Good day. We're the Group 6, and I'm Kathleen Santibañez, and today we're the discussants about the non-parametric statistics repeated measures. So together with my group, Athena Hermione Layese, Annie Sabiaga, and Caroline Soguilon. So our topic today is Lesson 6.1, the Wilcoxon Signed Wrong Test. So what do you mean by Wilcoxon Signed Wrong Test? So, it is a non-parametric equivalent of two paired sample t-tests. It is also measured over one sample. All participants experience all conditions. Alternatively, we may decide that the data are ordinal. So, the Wilcoxon signed wrong test is a non-parametric test used whether two dependent samples have been selected from two populations from the same distribution.
Assumption. Number 1. The independent variables should be measured at the ordinal or continuous level. Number 2. The independent variables should consist of two categorical related groups or matching pair. Number 3. The pair data have been obtained from a random sample. Number 4. The population of difference has a computer group that is approximately symmetric.
To solve for the test value, which was denoted by WS, rank the absolute values of the differences of each pair of data values, that is, when n is less than or equal to 30. Sum the positive ranks and the negative ranks separately. Select the smaller of the absolute value of the sums as the test value WS. However, when n is greater than 30, the normal distribution can be used to approximate the Wilcoxon distribution. So we need to use the formula Z is equal to WS minus n times n plus 1 over 4 all over square root of n times n plus 1 times 2n plus 1 over 24, where n is the number of pairs where difference is not 0, where WS is smaller sum in absolute value of signed ranks.
So here is our sample problem. A group comprising of 10 drafting students is interested to know if the accuracy of their drawing has something to do with the drawing tools that they are using. They rated their drawing as 1 to be not accurate and 4 to being very accurate, both before and after using T-squares and triangles. The students hypothesized that after using the right instruments, the accuracy of their drawing has changed. Is there enough evidence to support that using the right drawing instrument has a significant difference at 0.05 level of significance?
The test involves several steps to carry out the analysis. So here are the 5 steps in solving the Wilcoxon signed rank test. In step 1, you have to state the null and alternative hypothesis. In this case, the null hypothesis states that there is no difference in the accuracy of the drawing, while the alternative hypothesis states that there is a difference in the accuracy of the drawing. Moving on to step 2, wherein you have to find the critical value from the Wilcoxon signed rank test. Let us first identify whether this problem is either one-tailed or two-tailed. Looking at and understanding the problem, we can say that there is no direction, and so we can conclude that it is a two-tailed test. Since n or the sample size is 10 and the level of significance is 0.05, the critical value is 8, which can be found in the intersection. See the figure on my left side for your reference on how to locate the critical value. Whereas in the decision rule, you reject HO if the test value is less than or equal to the critical value, which is 8, otherwise you do not reject HO. For step 3, which is compute the test value, first we need to make a table. And add another column for difference, absolute value of the rank and signed rank. For difference, we need to subtract after from before datas. For the absolute value of the column, we need to get the absolute value by turning the negative ones into positive and then rank the absolute value. And for the signed rank, you need to copy the negative ones for those who have 1. Next is we need to get the sum of the positive rank. So for the positive rank, we have 7.5, 3, 10, 3, 7.5, 3, 3, 3, and 7.5, which have a summation of 47.5. And for the negative rank, we only have negative 7.5. So for the WS, we need to get the absolute value of the negative rank sum, which is the 7.5, and that is our test value.
Step 4. Make a decision. Reject HO since 7.5 is less than 8. Therefore, there is the difference in the accuracy of their drawing at 0.05 level of significance. Hence, using the right drawing tools affected accuracy of the drawing.
So this is an example of a real-life situation applicable to our major field of specialization, which is architectural drafting technology. The Wilcoxon side rank test may be used to understand whether there was a difference in the condition of the materials and construction industry before and after exposure to external factors such as water, air, and other chemical substances.
And that is our presentation about the Wilcoxon signed rank test. Thank you for watching, and to God be the glory.